To minimize risks, you've got to simulate the worst-case scenario. Crash tests are obligatory in Formula One. Whenever the drivers climb into the cockpit, they know they're racing in great safety, ensured by the monocoque, the safety cell, playing a key role in driver protection. I was recently at the company where they do these crash tests with the FIA, and the things the cars have to withstand. I mean, a huge weight's dropped on the car from above and it doesn't budge. You hear a bit of cracking sound, but nothing else happens. It's really impressive. The monocoques have been adapted this year to new regulations. However, the main rule remained the same. They've got to be almost indestructible. Tires, suspension, nose and wings. Set-up elements for top performance. The monocoque, however, has to protect the driver and must withstand anything that might happen out on the track. Carbon fiber, alias carbon, the magical word in Formula One when it comes to choosing materials. Twice as strong as steel, but 5 times lighter, and the key ingredient in the all-round package for driver protection. The crash test. This 780-kilogram sledge hits the monocoque at over 50 kilometers per hour. The safety cell itself remains undamaged, made extra rigid by integrated aluminium. The carbon sections of the car don't deform, but splinter instead. The impact energy is thus dissipated and force absorbed. Motorsport and materials, a science in itself.
Carbon fibres, very low density, lightweight, high stiffness, high strength. But a small, fragile fibre by itself is not practical for use in an engineering application. So you need to often weave it as you would a normal fabric for clothing, for example. And then you bond the fibres together using a resin system. Now that resin system is then reacted after you've made the shape.
Despite impressive results, the safety standards are constantly being tightened. As of this season, rear-end crash tests are now performed at 15 meters per second instead of the previous 12. That equates to 54 kilometers an hour of pure impact speed. Compared to reality and the top speeds of a Formula One car, that may not sound much. However,
a crash test is just about one condition. So if you're going to crash in a forwards direction, I mean, we go into a barrier which has no compliance whatsoever. If you hit that, it's a solid barrier. So when you hit it during our crash test, we are looking to dissipate all of the energy that the car has in hitting that solid barrier.
The principle of rigid passenger cells applies to passenger cars too. As in motorsport, safety in general motoring is also based on crash test results.
You
can see very clearly from this modern passenger car what a crumple zone can achieve. This car has crashed against a barrier at 56 kilometers an hour, and the front of it is shortened by almost 1 meter. However, all the deformation has been contained, as it should be, in the front section of the car, while the entire passenger cell has remained completely undamaged. You can see that very clearly when you open the doors. The passengers can be rescued easily without any effort. In fact, not even rescued, they can simply get out. Safety belts and airbags have ensured that their risk of injury is very low. Optimum protection for optimum performance. Thanks to the high standards of safety in Formula One, the drivers have no need to worry and can concentrate on the main matter at hand, on the race.